Okay, so we're looking at increasing and decreasing in analysis in the AST questions in the short response. Obviously, it doesn't apply to multi-choice. Okay, so when we've got questions that we're looking to compare sets of data where you might have an increase or decrease, so you're just trying to compare things, let's try not to say that there simply was an increase or decrease or a difference. We're going to try to use analysis. Okay, so the question that we had in the 2009 paper, okay, so this is the 2009 paper, which you did practice. Okay, so let's look at just something simple, the number of dairy farms. So the scale is times 10. It's halfway between 11 and 12. So we've got 115. And where it finishes is halfway between 7 and 8. So it finishes at 75. So there's a bit of analysis straight away. You could also say that there's a steady decline because the line is fairly straight. So you could say there's a steady decline because the data is basically a straight line. So that's a little bit better. But to say that the farms decreased, that is not analysis. Like as we've said before, year 7 can see the line has gone down, so the farms has decreased, but that's not high-level analysis. So if we say the farms decreased from 115 to 75, that's analysis because you've interpreted the scale. But for instance, if these numbers had just been pulled from the table, that wouldn't be analysis. That's just proving you can read. So we have got some analysis, but let's look at how more analytical you can be. So farms decreased from 115 to 75, and we're going to try to use percentages as a comparison. We're not going to worry about fractions, we'll use percentages. You could use fractions, but we'll use percentages. Now some the calculations are quite easy. So we always compare with what you started with. So you always look at the initial amount. And if you look at just 10%, that's just 11.5, because we just have to move, well, technically we're not moving the decimal place, the number's moving, but if you just move the decimal place one spot back, that's 10%. So 10% is 11.5, double that is 23, add 11.5 is 33, double 23 to 46, and you've got your 40% answer. So that's what we're going to do. So the farms decreased by 40 farms, okay? And so we say, well, 40 farms is between 30 and 40, so now we've got some analysis. We've said that the farms decreased by about 35%. You don't say exactly 35% because you don't have a calculator. So a 40 farm decrease is about 35%. And when you look at other bits of information, like if you look at the milk production or something like that, and you might see that, comparing the farm decrease with the number of cows or the milk production, we might make some more comparisons. Okay. So let's have a look at the milk production and see if we can do the analysis. Okay, so it starts, okay, you always look at the initial amount. That's the critical part. And then it decreased to 4, and then it increased. Now, when you look at the graph, there were two different lines. There were two different increases. So you might say, for instance, that milk production declined and then increased, but it increased at different rates. So you could say it increased at a faster rate till 1981 or something like that, and then increased at a slower rate. But let's look at percentages. Okay, so we look at the initial amount, and 10% is 0.5, double it, add 0.5, add 0.5, add 0.5. So there's some numbers that you're going to use. So looking back here, farm milk production decreased by 1 megalitre, so we've got a 20% decrease between 1976 and 1981. And then increased, okay, so between 5 and 7.5 is 2.5. So then milk production increased by 50% from the initial amount. Okay, so we had a 20% decline. So rather than just saying it declined, we say it was a 20% decline and then an overall growth of 50%. And it changed at different rates. How else could you add to the analysis? Well, okay, so we've got, rather than comparing it to the initial point, we could compare it to the lowest point and then see how much between 81 and 2016, what that percentage changed. And you can see it nearly doubled. Okay, it didn't quite double, but it nearly doubled. So again, we just do the 4 as the initial rather than the 5, and then just go back one decimal place and then just keep adding. And so in actual fact, so we've got 3.5, so actually 3.2, 3.6. I've actually made a mistake in my slide. So final milk production was about 65%. No, it's about nearly 90%. Nearly 90% higher from 81, which was the lowest point. And when you look at the cow production, so cows was constant from 81 to 2006. There were no change, 0% change in cows, but milk went up 90%. So there must have been better techniques. Like there's more milk and no change in cows, but a 90%, you've nearly doubled your milk. So there must be, better techniques or better efficiencies or new technologies. You don't have to say what they are. You're not a farmer. Okay, so that gives you an idea. So let's have a look at the next page. So let's have a look. Work out, just pause the tape and work out what the percentage change is for cows going from 2,000 cows to 1,500. So if you just remember, going back to the cows, okay, so cows are being multiplied by 2,000. So 2 means it's 2,000 cows, and then it's dropping down between 1 and 2, so that's dropping down to 1,500. So that's the analysis, rather than saying, some people didn't even see the decrease, but the cows are decreasing and then they stay constant. Okay. So work out, pause the tape and work out what the percentage change is. Okay, so we're back again. So the initial was 2,000. So 10% go back one place. So 20% equals 400. 30% equals 600. And there was a 500 cow decrease. So therefore, there was a 25% decrease in cows from 76 to 81, and then no change. Okay, so that's analysis, and that's what you could have done as a description of that line. Okay, so let's move along. So let's take a look at the hamburger question. Again, you have to make comparisons inside the burgers and between the burgers, but let's just have a look at some of the things that you could have talked about. And there's numbers here. Okay, so we could make it we'll just talk about the fat. We won't worry about the energy per se. Let's have a look at the fat. Okay, so in the beef burger, lean beef, beef burger, bacon burger, there was 9, 15, and 49. So obviously you could say there was a 6, I'm not too sure what the scale is, grams per serve. So rather than just saying there was a 6 gram per serve increase or 40 gram per serve increase, let's look at the percentages. So if we look at 9 being the initial, we always start from the initial, 10% is 0.9, and let's just round it. 0.9 is about 1, so 6 would be 60% and 40 would be 400%. So we can say that that the beef burger had 60% more fat, but the bacon burger, beef and bacon, had more than 400% more fat. But if you look at, for instance, the energy, okay, there's not a 400% increase. So you could say that even though there's a 400% increase in fat, there wasn't a 400% increase in energy per serve. There was an increase, and you could work out what that increase was. So adding bacon was a 400% increase in fat, but then if you look at the chicken, okay, between chicken and bacon, there was only a 7 gram per serve increase. And so going back to the initial amount is 20, so 10% is 2, trying to get up to 7 as quick as we can, so triple it is 30, and then add, actually 40% would be 8. 6 plus 2 is 8. So to get to up to 7, we're halfway between 30 and 40, so there's a 35% increase in fat, grams per serve for the chicken burger, but there was a 400% increase in fat for the beef. So you can have a discussion about that. So if you're talking about, if you're going to increase the fat, perhaps the chicken burger was a less of an increase in fat. Okay, so I think that's our last slide. So hopefully you got something out of that. Let's try if we have any more practices to look at analysis using percentages. Okay, thanks.